All right, so today we're learning your third method for solving systems of equations. And this method is elimination. All right, now elimination only works when your x and y values are lined up on the same side of the equation. Okay, so most of the equations that are set up for elimination will be written in standard form. Okay, most of the equations. So we see the first system here. X plus 3y equals negative 2. X minus 3y equals 16. All right, both equations are in standard form. Would you agree? The x and the y are on the same side of the equation. So if I want to use elimination, I'm looking for either my x values or my y values to be opposite each other. They have to be exactly the opposite, okay? And I'm going to add the equations together. All right, now be careful. Are your x's opposite? No, they're the same. So if you were to add those, you would get 2x. That does not eliminate your x. But what about your y values? 3y and negative 3y cancel, okay? So you can cross those out. What you're doing is you're adding the equations together. Again, elimination can be helpful when I see those opposites. So what is x plus x? 2x. And now I'm going to add together the number values on the other side. What is negative 2 plus 16? 14. Now divide both sides by 2 and finish solving the equation. X equals 7. Okay? And just like that, I've solved for x. Now, I need to go back to the original problem, and you can do either one. Okay? You can plug in 7 for the first x, or you can plug it in for the second x and solve for y. Either one. All right? I'm going to pick the first equation. Why do you think I would pick the first equation? It's technically preference. Because 3y is positive, okay? Now, again, that's not going to make a huge difference, but, you know, again, just preference. You can pick either one. So I plug in 7 for x, so 7 plus 3y equals negative 2. All right? Now I need to solve for y. So talk me through it, guys. What do I do next? Y'all just talk to me.
You subtract 7.
Yeah, subtract 7.
And then 3y equals negative 9.
Uh-huh.
And then divide both sides by 3, and y equals negative 2.
Okay, so divide both sides by 3. And y equals negative 3. All right, so I still have not written my solution. Now, I solved for both of them. This happened a few times earlier this year when I taught this in pre-algebra, okay? They would just leave their answer like this. What is the answer, though? What's the answer? 7 and negative 3. You must write it as an ordered pair. So guess what? If you had solved this system with substitution, guess what your answer would have been? Same thing. If you had graphed both of these equations, guess what your answer would have been? Same thing. Okay? It's whichever method is going to get you to your solution the fastest, or with the least amount of pain, okay, and suffering. All right? Okay, you can smile. It's okay. We can smile in pre-algebra. Okay? All right, look at this next equation. Look at this next equation. So let's just say I can use any method. Any method is on the table. You think I want to graph those? No. You think I want to use substitution? No. Okay. Now, are my x's and my y's lined up on the same side of the equation? Yes. Do I see any values that are opposite? My y's are opposite. So instead of messing with these equations, trying to get it in slope-intercept, I'm just going to use elimination. Eliminate my opposites and add everything else and bring it down. So what is 2x plus 4x? 6x. And what is 9 plus 21? 30. All right, now what do I do? What do I do now? Just talk to me.
Divide both by 6.
Yeah, divide them both by 6, and x equals 5. So now I have half of my answer. All right, how do I solve for y now? How would I solve for y?
You plug it in.
Plug it back in. Now, are you guys going to choose the first equation or the second equation?
The first one.
The first one's fine. I'm going to choose the second one. Why do you think I'm going to choose the second one? Because y is positive. I don't want to deal with a negative y that I'm solving for. But again, if you pick the first one, just don't mess up your negative. You'll be fine. All right, so let's plug it in. 4 times 5. I plugged in 5 for x plus y equals 21. Well, what is 4 times 5?
20.
20 plus y equals 21. Subtract 20 from both sides. Y equals 1. So my ordered pair, my solution, is 5, 1. All right, put it in parentheses. That's the solution. So where would they cross if I had graphed these instead? Where would they cross? On the ordered pair of 5, 1. All right, are we making that connection, guys? So I want you to see all 3 methods as a way to solve systems. Okay?
What do you do if they're not lined up? Because you asked us that before we solved.
If they're not lined up. Oh, you'll see. Right now we're just kind of practicing the same so we can get used to the patterns. You'll see that more probably in tomorrow's lesson. But that's a good question. All right. All right. Any other questions? Okay. Next one. I want you guys to try this one on your own. Okay. So we've done 2. If you don't have it perfect yet, that's fine. If you get stuck, that's fine. All right. I just want to kind of walk around and check on you guys more one-on-one, and then we'll come back to this one and do it together. Okay. So what did you cancel? What did you cancel? You canceled your x's. X minus x cancels. Remember, you're adding these equations together. So 3y minus 1y. 2y equals 2. Divide both sides by 2. Y equals 1. Okay? How'd you guys do? Walking around? I think everybody's pretty squared away on that. Now, what do I do to find x?
You plug in 1 for y.
Okay, I'm probably going to use the first equation. All right, so I have to deal with a negative variable. So I get x plus 3. Can I just do 3 times 1 in my head? Pretty easily. All right, I'm totally fine with that if you guys do that. If you want to show that step, that's fine too. X plus 3 equals 5. Subtract 3 from both sides. X equals 2. All right, 2 and 1. Okay, how'd you guys do?
Good.
Do okay?
That one's probably the one that...
Yeah, it might have been kind of the quickest. All right, I have a lot of these examples in here.
We still have 3 more.
Okay, I'm going to skip this one because you guys did so well on that one, okay? And that'll just free up some more time for the independent practice at the end. Okay? All right, now, look at this next one. What do you notice about this next equation that's a little different? It's a little different. Talk to me, guys. What do you know? I don't have any opposites, okay? I don't have any opposites. So, and again, I'm being asked, and on your quiz and your test, you will be asked, solve it with elimination. So elimination, that's my method. So what you need to do is you need to create the opposite. You need to decide between my x terms and my y terms, okay, which one is divisible into the other, okay? So let's just start with y, because y doesn't work. Is 4 divisible into 5 evenly? No. Okay, so look at your x terms. Is 2 divisible into 6 evenly? Yes. So I can multiply. Now, if I need to multiply my x term, that means I have to multiply the entire equation. Okay? So what would I multiply 2 by? Let's just start with the number first. What would I multiply 2 by to get to 6? 3. Now you have to decide the sign. Because remember, it must end up being the opposite of negative 6. Well, if I multiply this right now, it's going to be negative 6, right? So I need to multiply this by negative 3 to make it positive 6. And now it will be the opposite. All right? Now, I don't want you to skip this next step. I know that it can be a little bit of a hassle, but I promise the more you get used to it, it'll go quicker. All right? Okay, so the first equation you didn't change. I want you to rewrite it. Please don't skip this step on your quiz Friday. Now, on the second one, you're going to distribute this negative 3. And now you're going to rewrite it underneath the equation that you just rewrote. So negative 3 times negative 2x is what?
Negative 6.
Positive. All right? So that was my whole goal, to create the opposite there. Now, negative 3 times negative 4y. What is that going to be?
12y.
Plus 12y. The signs are going to be really important, guys. Now, what is negative 3 times positive 14?
Negative 42.
Yes, negative 42. All right, now I'm ready to add the equations together. Okay, so opposites cancel. What is 5y plus 12y?
17y.
17y. You might be thinking, there's no way this is going to end up being a whole number. Okay, you could be right. What is 25 minus 42?
Negative 17.
It is negative 17. Negative 17. So that is nice, because now when I divide both sides by 17, y equals negative 1. Okay? Now, calculators will be allowed on this quiz and test.
Are there
All right?
any quizzes or tests that we're not on there?
Yeah, the exponents, which pre-algebra just survived. Okay, actually, then the chapter after that they're in real numbers, you can't use a calculator, because it's like, what's the square root?
Oh.
Well, you can't use your calculator for that. Okay, all right, so now how do I find x?
Plug it in.
Okay, plug it back in. Does it matter which equation you use?
No. Would you use the one?
No.
You use the original?
You can use the new one. You can use the original ones. It's not going to matter. Literally, it's just whatever your preference is. All right, so I'm just going to use the first one. So I have negative 6x minus 5, because positive 5 times negative 1 is negative 5, equals 25. All right, now I keep solving for x. Add 5 to both sides. To me, one thing I like about systems of equations is it's kind of a tangled web, right? Like when you first start solving it, you have no idea what your answer is going to be. All right? But then isn't it nice how the more you solve, it just starts working out? Now I divide both sides by negative 6. And what does x equal? Negative 5. Negative 5. Now put them together for your answer. Negative 5, negative 1. So if you had chosen to graph them, they cross at this ordered pair. Okay, solving by elimination. This is definitely the harder part of solving systems with elimination, is when you don't have the opposite and you have to create the opposite. All right, what do you see here? What do you guys see here?
It's in
These are, one's in slope intercept, the other one's almost in slope intercept. Okay, do it in your homework section because it's not there.
There's a blank space.
Okay, I need to kind of rearrange this a little bit, or in blank space if there's some blank space. Thank you, ma'am.
So we're changing it for the other one?
Okay, so I just need to switch these around. Remember, the x's and the y's need to be lined up on the same side of the equation. So all I need to do is switch these two around, okay? So let's go ahead and do that. Let's just rewrite it. I have 5y equals negative 5x plus 15. All right? Then I have y equals negative 2x plus 3. Now remember, I want either my x or my y to cancel. So is 2 divisible into 5 evenly? You don't want to mess with decimals, okay? Is 1 divisible into 5 evenly? Yes, it is. So what could I multiply this second equation by? 5. Can multiply it by 5. All right. This is about as hard as it gets with elimination. So now, negative 5. I need to make it the opposite. Okay. So first equation, I rewrite one more time. 5y equals negative 5x plus 15. And then negative 5 times 1y is negative 5y equals positive 10x minus 15. Oh my goodness. Okay, so now let's bring everything down. 0 equals, what's negative 5x plus 10x? 5x plus 0.
We have to add plus 0.
No, you can just cancel. So you can say 0 equals 5x. That's fine. What happens when you divide both sides by 5?
0.
X equals 0.
No.
X equals 0. So now, when you plug it back in, all right, let's just use this first equation. All right, because it already has y solved for. All right, plug it back in and solve for y. All right, so y equals negative 2 times 0 plus 3. So what's negative 2 times 0?
0.
So y equals 3. So this solution is 0 and 3. All right, now that ended up being a little goofy, which is why I put this one in your PowerPoint slide. Guys, check this out. If you were to plug these in and test your solution, okay? Negative 2 times 0 is 0, y equals 3. It also works on the first equation. If you were to plug those numbers back into the equation and check it, it works out, okay? So 0, 3 is your solution. All right? So which approach, is this in your notes?
There's something called which value would you choose?
No. I'm going to skip that one because that's actually in your lesson for tomorrow. That's fine. Well, no, let's go over it. Which approach would you use if graphing was an option too? Like say you had a graph there. Which one would you do? Okay, Sebastian says substitution. Totally would work. I heard graphing. That would also work. This would be ideal for graphing. Elimination could work, but you're going to have to do a little bit of work to the equation because I don't have any opposites as it is written right there.
Actually, graphing would be
Which approach would you use on this system?
elimination.
Why would you say elimination? Because your y's cancel. So that's usually my go-to. If I see opposites, I'm going to use elimination all day. Okay? Which approach would you use on this one? Be careful. Be careful. Be careful. Be careful. Ugh, that would be the last one I would choose. Can you say the two y's cancel?
Yes.
No, you cannot. Why not?
One of them is not an elimination.
They're not on the same side of the equation. 2y's on the right side, negative 2y's on the left side. Okay? I would do substitution on this one. X equals 2y plus 7. Plug it in for x on the second one. Elimination does not work. Does everybody see that? Okay? All right. What time is it? 8:33. Let's see. I want to save, because tomorrow we're going to have some time. I want to just build the foundations. We did this yesterday too. Actually, we did this yesterday in 4th hour. We did the word problem with you guys. All right. I want to save the critical thinking for tomorrow and Thursday, because I want to just build a strong foundation with just solving the equations. Before we start writing our own equations, we'll use some of IXL to do that. Their modeling real life questions are really good. Okay, so for today, we're going to go ahead and time out here so we have time to practice these together.